Hey, me again. All right, this is your last video that you need to watch for Algebra 2 this week. Lesson 8.4. I'm going to try to not go too quick, but some of these problems will be a little quicker than some of the other ones we've done. So in this section, we are adding, subtracting, and multiplying radical expressions, and you will be using all of those rules that we've been talking about in earlier sections of this chapter 8. So if I have radicals that have the same index, so again, index is that little n value outside this number right there. So in a square root, the index would be 2, a cube root, the index would be n equals 3, yada, yada, yada. Radicals with the same index and the same radicand. So again, radicand is the value that is under the radical sign. Those are called like radicals. So over here, I have 3 rad 5, 6 rad 5. The rad 5s, those are like radicals. And what we can do is we can just add, you can almost think about the numbers before as like a coefficient. So I can just add 3 plus 6, and that's going to equal 9. So I can simplify this into 9 rad 5. This is basically what we're doing today, okay? But down here, over here, these are unlike radicals because this one has a little hidden 2, and this one has a 3. They don't have the same index. I cannot combine those. That statement right here is as far as I can go. It's going to have to stay as 3 rad 5 plus 6 cube root of 5, okay? So add or subtract as indicated. I have radical 3 plus 7 rad 3. Are these like radicals? Yes, these are like radicals. So I can go ahead and just say, hey, what is 1 plus 7 rad 3? That's just going to give us 8 rad 3. And that's your answer right there, okay? So again, if you don't see anything outside here, it's a little sneaky 1. Okay, over here, are these like radicals? Yes, rad 2 and rad 2, they both have the same radicand, the same index. So I can just say, hey, what's 10 minus 4 rad 2? That's going to give us 6 rad 2. You can also kind of think about going from this step to this step as like factoring out the like radical. But eventually, I think you guys will just get into the habit of treating the 10 and the 4 honestly kind of like a coefficient, like 2x plus 4x. You just add that to get 6x. 10 rad 2 minus 4 rad 2, you're just subtracting to get 6 rad 2. All right? Again, pause as needed, and yeah, do what you got to do. Example 7. Add or subtract as indicated. So over here, are these like radicals? Nope. So I cannot simplify. That's as far as I can go. I can't write that any differently. Are these like radicals? Nope. So I cannot simplify. That is as far as these are going to go. All right. Sometimes we will have problems where we need to rewrite the radicals, and then I'll actually be able to combine them. Okay, so we're going to do that in example 8 coming up next. Add or subtract, assume that variables represent positive real numbers. So as these stand right now, these are not like radicals. So right now, not like rad. But I can rewrite these. I can simplify these a little bit. So the square root of 20, well, that's the same as the square root of 4 times 5. Radical 4 times radical 5 is just going to simplify to 2 rad 5. Square root of 45, well, that is going to split up into 5 and 9. So the square root of 5 times the square root of 9, well, the square root of 9 is just 3, and I'm left with rad 5. Okay, so I like this. Square root of 20 just becomes 2 radical 5 plus 2 times the square root of 45, which became 3 radical 5. I can just multiply the 2 and the 3, right? All of these terms are being multiplied here. So 2 rad 5 plus 6 rad 5 is going to result in 8 radical 5. And that would be your final answer for this problem here. All right, so what we did was we said, hey, they're not like radicals. So I'm going to rewrite them. They became like radicals, and then we could combine them. Let's see what we can do on this side over here. So cube root of 54 would split into 27 and 2. So the cube root of 27 times the cube root of 2 would simplify to 3, and then the cube root of 2. Over here, cube root of 16, well, this would split up into 2 and 8. So the cube root of 8, sorry, I have a 5 here too. 5 times the cube root of 8 times the cube root of 2 is going to simplify into 5 times 2 times the cube root of 2. I'm going to simplify that a little bit later, multiply the 5 and the 2. And then over here, cube root of 2. Can I do anything with her? No. Okay, so she just gets rewritten here plus cube root of 2. But now, boom, 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 these are all like radicals. We just need to do a little simplification first. So I have 3 cube root of 2 minus 2 times 5 is 10 cube root of 2 plus cube root of 2, that's a little sneaky 1 over there, 3 minus 10 plus 1 cube root of 2 is going to give us negative 6 cube root of 2. All right, so again, I'm starting by rewriting or simplifying until I get like radicals, and then I'm just combining like radicals. All right, let's try another one. Add or subtract. Can I simplify anything here? Because right now I don't really have like radicals going on. Like I can't combine any of these. They are all completely different. But cube root of 64, well, we know at this point that that's just 4. So I have 4 plus the cube root of 14 minus 9. Okay, now I have 2 like terms, 4 minus 9. It's going to give us minus 5 plus, or negative 5 plus the cube root of 14. And that is as far as we can go. That would be our answer there. You could also, because they're added, you could also write this as the cube root of 14 minus 5. Either of those would work. We typically, I guess, like to write the numbers first before the irrationals. Cube root of 14, I can't simplify anymore, so that would be irrational. All right, try this one out on your own. Obviously, I can't force you to because I'm not there, but try this one out on your own. Pause the video and then come back and see if you got the same thing. Otherwise, I'm just going to keep talking. So it feels like you've paused the video. Okay, great. Let's go. So I have negative square root of 75 plus the square root of 12 minus 3 rad 3. None of these are like time. These are all not like radicals right now. But square root of 75, well, that would break up into 25 and 3. So I have negative square root of 25 times square root of 3. That's going to simplify to negative 5 times the square root of 3. 12 would split up into 4 and 3. So plus the square root of 4 times the square root of 3 plus 2 times the square root of 3. Minus this one now is a like radical, so minus 3 rad 3. Sweet, let's combine them. Negative 5 plus 2 minus 3 square root of 3 is going to give us negative 6 square root of 3. And that, folks, is our answer. All right, y'all, we have a few more examples left. Hang in there. These are going a little quicker than before, right? Okay. We're getting a little more complicated here. So again, like radicals, need to have the same index. So here, doing well with that. The index is that little secret hidden 2, right? They're both square roots. That's good. But one has a 5x and one is a 45x cubed. I need to make sure they both have the same radicand. They have the same thing underneath that radical sign. So this first one, I'm going to rewrite this one right here. I know that 45 can split up into 9 and 5. And I know that x cubed I can also rewrite. So I want to keep my perfect squares up front. So 9x squared I'm going to keep up front. And then 5 in the other x. That's going to be my second term here. So again, what I've done is I've separated 45 into a perfect square and its other factor, 9 and 5. I separated x cubed into a perfect square, x squared, and its other factor, x. I can separate those now. So square root of 9x times square root of 5x. I can simplify. Square root of 9x squared is just going to be 3x. So that's going to give us 9x square root of 5x. And then over here, now they are like terms, right? They both have the radicand of 5x. So in a like radical, you can have variables. You can have x, y, whatever you want. You just have to make sure the radicand is the same for both. So plus x square root of 5x. I'm going to do the same process I did. Even though I have x's, it's the same process. 9x plus x, radical 5x. That's going to give us 10x square root of 5x as our final answer here, our simplified answer. So same process. This was just a step up dealing with a few more variables. Okay, we're going to apply our quotient rule a little bit here. This is actually kind of going back. This is kind of what we did in 8.3. So again, that's kind of why I'm combining 8.3 and 8.4 on the same day. I know that it is a lot of problems, but these all are so tied together and so related. So for this one, I want to use my quotient rule, and I want to rewrite this as a large square root of a to the 7th b to the 6th over a to the 3rd b squared. How would you all simplify that? A to the 7 over a to the 3rd, well, that would be a to the 4th, right? 7 minus 3 is 4. B to the 6 over b squared, that would be b to the 4th. Okay, cool. Now, how do I simplify again? Well, the square root of a to the 4th is just going to be a squared. Again, if you need to, use that rule from a day or two ago. A to the 4 over 2 is a squared. And then same thing, right? Square root of b to the 4th is just going to be b squared. So that's your final answer, folks. Not too bad, right? All right, we have a few more. I think I have 13, 14, 15, and then y'all are done. Here's where we get into multiplication a little bit. I just want to show you guys, I know it feels like, yeah, I'm giving you a lot of problems, but I want to show you that even though they're radicals, you can do things that you've been doing for years with them, okay? So for this first example, if I didn't give you any radicals or square roots over here, you would probably just take this number in front of the parentheses and distribute it to both of these. That's exactly what we want to do here, okay? So I'm distributing it over here. I have the square root of 5 times 6 plus the square root of 5 times square root of 50. Okay, let's try to see if we can simplify. I tend to like to write the number in front of the square root, so that's 6 rad 5. How would you guys combine these? Rad 5 times rad 50? Okay, yeah, I would just multiply. So 5 times 50 gives us 250. Can we simplify that? Okay, well, 250, that splits into 25 and 10. So I have 6 radical 5 plus the square root of 25 times the square root of 10. 6 radical 5 plus, well, that would be 5 square root of 10. Can I combine these two? Can I add these? Well, no, because they're not like radicals. So this is as far as we can go here. We've multiplied and then we simplified. All right, over here, you guys, if I gave you something like this, x plus 3 times x minus 4, you would FOIL it. You would multiply your first terms, your outside, your inside, your last. That's exactly what we're doing here. Okay, so I'm going to multiply my first terms, or maybe some of you would prefer the box method. You could apply that here as well. That would also work. So my first terms are going to be radical 11 times radical 3. So those are my first terms here. Plus your outside terms. I have radical 11 times 2. Those are my outside terms. Then my inside terms, I have negative rad 7 times rad 3. So negative rad 7 times rad 3. Those are my inside terms. And then I have my last terms minus rad 7 times 2. So those are my last terms. All right, let's just clean this up a little bit. The first ones I can combine using my product rule. So that's going to be square root of 33, 11 times 3. Plus, for this one, I can't really combine them, but I do want to put the 2 in front of the square root. Over here, I can combine these. 7 times 3 is going to give us 21. Over here, I would like to put that 2 in front of the square root sign. Do I have any like radicals here? Can I combine any more terms? Okay, no, 33, 11, 21, 7. I can't simplify those, and none of them are the same. So this right here, this whole expression would be your final answer, okay? But you're foiling, guys. You've done foiling. We are just taking it, applying it in a slightly different way, okay? So we're adding this complicating step of dealing with these radicals. You guys can do this. I have full confidence. 2 more, people. All right, anytime I'm squaring something, make sure that you rewrite it like this and FOIL it. Or I guess you could use that a minus b squared formula that you guys had a little while ago. Either way would work. So over here, I'm going to multiply my first terms. So I have 2 times the square root of 5 times 2 times the square root of 5. Those are my first terms. Then I have my outside terms. So that's going to be minus 2 times the square root of 5 times 1. I don't really need to write the 1. I will for right now just to be consistent. Minus my inside terms, minus 1 times 2 square root of 5. And then I have my outside terms. So these ones were, that was outside. These were inside. And then I have negative 1 times negative 1, so plus 1. Those would be my last terms. All right, let's see if we can combine anything here. So my first one, I have 2 times 2, that's going to be 4, times square root of 5 times square root of 5. What would that be? Okay, that's just 5. So 4 times 5, that's going to just become 20. Over here, this 1 I didn't really need to write, so that's 2 times the square root of 5 minus over here. It's actually also just 2 times the square root of 5 plus 1. Okay, so these two now are like radicals, so I can combine those. Negative 2 minus 2 is going to give us negative 4 rad 5, and then this plus 1 is hanging out. Now I have another set of like terms, 20 and 1. Your final answer here, folks, is 21 minus 4 square root of 5. Okay, so for this one, I rewrote the square as 2 rad 5 minus 1 times 2 rad 5 minus 1. Then we FOILed that out. We simplified in this step where we could. And then over here, I combined like terms. I combined like radicals. And then again, I combined like terms with the 20 plus 1 to get our final answer. One more, and then y'all are done. Congrats. Okay, last one. There's a shortcut here. What does this remind you of? What does this look like? You can FOIL it all out. Like, that's fine. You could do this. But maybe we recognize that this is in the same form as difference of squares. A minus b times a plus b. What does that equal? A squared minus b squared. I can do the same thing here, okay? So this whole thing is my a term, and this 7 is my b term. So I need to rewrite this as the square root of 3x squared minus 7 squared. What does the square root of 3x squared simplify to? Well, the square root and the square kind of undo each other, so just 3x minus 7 squared is 49, and that's your final answer there. All right, as always, email if you have questions when you're working through the delta math, and I will see you guys next week.